And we're going to start this thing called a hypothesis test. Hypothesis test is what we got going on in statistics. A hypothesis test allows us to be able to say, you know, oh, you claim that there's 20% M&Ms. Well, let me take a sample, and I have evidence that there's not. So I have just proved that you are lying, that there's not 20% blue M&Ms, if that's what we were doing, 20% blue M&Ms. So a hypothesis test allows you to make a decision, a yes-no decision about if a claim that somebody makes is true. Okay, just last period I had a problem where a neighborhood was complaining because the cars were going too quickly through their neighborhood. The speed limit was 30 miles per hour, but they thought that it was higher than that. So they took a sample to see if they could say, no, the average is not 30, it's actually higher. All right, so today we're going to break this whole test process down. Today we're going to get an idea of what this thing called a null hypothesis is and the alternative hypothesis statement. Okay, we're going to be able to, well, we're actually not going to check conditions. It says we're going to check conditions to make sure the normal model applies. We won't really quite do that yet, but we eventually will, and we'll eventually calculate this thing called a p-value and put it in context. And that's your favorite thing to do, because then that means we have to write sentences about what's going on in the real world with this stuff. Oh, well, we've just started 20, and so it's going to be a while. All right. So here we go. The first thing we need to do is determine what a parameter is, and you have already practiced this, so this topic's not entirely new. It is about the entire population. So for example, we will say P equals the proportion of yada 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 about the whole population, or you will say mu equals the average speed of all cars in that neighborhood, or whatever it is that that problem is about, okay? We have to make sure that it is in present tense or future tense, no past tense. You do not need to make an inference about what has happened in the past. All right, so let's practice this. Here's problem number 1. Census data for a certain county shows that 19% of the adult residents are Hispanic. So in the entire county, there's 19% Hispanic. Well, suppose that 72 people are called for the jury duty and only 9 of them are Hispanic. So they got a sample. 9 of the 72 were Hispanic. Okay? So does this apparent underrepresentation, so does this sample that they got make us call into question the fairness of the jury selection system? Okay, so the first thing that we want to do is we're going to first just define what this problem is talking about. So is this a mean problem or a proportion problem? It is a proportion problem. So the parameter we will define will start with P equals the proportion of, and what is this? What are you looking at? Oh, sorry, here you go. We're looking at, what group of people do we look at?
The Hispanic.
We're not looking at Hispanics, we're looking at the jurors. And we're seeing the proportion of the jurors that are Hispanic, yes. So the proportion of the jurors, that's a juror, that's a person that was chosen to be on the jury in a criminal case. Proportion of jurors that are Hispanic. Okay? So that means they're going to call in, you know, pretend like you go into law. If you go into law and then you are going to be defending a Hispanic client. Well, you don't want to have, you know, like no Hispanics on the jury committee. You would like to have a lot of Hispanics because of perhaps racial issues and stuff. So you want to make sure that if there's 19% Hispanics in the community, you want to have at least 19% on your jury committee. So as a lawyer, you're going to try and fight for that and say, hey, I need at least 19% Hispanics on my jury. All right. Now, let's go ahead and practice this thing called a null hypothesis. Oh, I think actually that's for the next page. Let me check here. Yeah, we'll talk about the null hypothesis and alternative shortly. All right, let's do this next one. Problem number 2. In 2001, a national vital statistics report indicated that about 3% of all births produced twins. So, oh, that's all we're writing for the first one. Yep, that's all we're writing for the first one so far. That's all this is right now. Okay. So hold on. So, vital statistics reported that about 3% of all births produced twins. Is the rate of twin births the same among very young mothers? So they say everybody has twins at 3% rate. Do teenage pregnancies have twins at the same rate, or is it different? Okay, so data from a large city hospital found that 7 sets of twins were born to teenage girls. Test an appropriate hypothesis. Let's write our parameter. Is this a mean problem or a proportion problem? Okay, it's proportion. So we're going to start off saying P equals proportion of what? But let's make sure we put our denominator as the first thing. Proportion of what? Good. The proportion of teenage pregnancies. So always put your denominator right there. That's actually a pretty important concept to think of. Make sure that's always your denominator. Proportion of teenage pregnancies that result in what? Good. That result in twins. Okay? And then we're going to eventually see, is that the same as 3% overall? Okay? All right, so let's leave those for a second. We may come back to those and add something to them shortly, but let's take a look at the next page where we're learning what this thing called a null hypothesis and an alternative hypothesis statement are. So here we go. A null hypothesis is a statement that always has, or that is always a statement about what is claimed to be true. It always has an equal sign in it, and the format of it will look something like this. H with a little O, colon, and then you put your parameter P equals or mu equals, and then the number. So I could also say something like this. H with a little O, and if this was a mean problem, I would put mu, equals maybe 10 miles per hour or something like that. So that's what a null hypothesis, the way the symbols are written, okay? This is, if it is a proportion problem, if it's a proportion problem, you have P equals. If it's a mean problem, you have mu equals. All right, so now the alternative hypothesis statement is a statement about what type of sample would potentially give us the ability to reject the null. So it's kind of like thinking, the alternative is something where we wonder, what is it that we're wondering about this problem? Do I think that cars are actually averaging faster than 30 miles per hour? Do I think the twin births is higher, the twin births to teenagers is higher than everybody else? Do I think the Hispanics are being underrepresented? Okay, so let's think about some of these kinds of words. So the alternative hypothesis statement, or the signs, will be either a less than, if things are, we're wondering if they're less than, or underrepresented, or fewer than, if we're greater than, okay, if we're wondering that they are more than, okay, actually then this is kind of down here at the bottom. So less than would give us words like underrepresenting, much less severe, lower than expected, something is happening quicker in less time. More than words would be something is being overrepresented, it's much more severe, it's more effective, higher than expected, slower time. Not equal to. A not equal to alternative would be if they say, is the teenage pregnancy rate different than the overall rate? Or has it changed? Okay? Has something we've done created a change? So let's practice this. Actually, before we practice those, why don't we go ahead and come back here and write the null and alternative for these as well. So let's go back here. So the null hypothesis for this problem, and then we will have an alternative. So you can do an HO and an HA, okay? So HO colon and HA colon. So again, this is a proportion problem. So what is the claim? What should be happening? What proportion should we have on the jury? We should have 19% on the jury. If 19% is in the county, then that's the percent that should be on the jury. So the null hypothesis is that P, what? Equals, and I'm just going to go ahead and always do these as a decimal, 0.19. The percentage that is claimed, yes. The one that they say the population is. Okay, how about the alternative? We're worried that they're not being fair. So we're worried that we're getting what? Good. We're wondering if we're having an underrepresentation. So we think that if I have evidence to reject, then I can say P is less than 0.19. And you're kind of not being fair to the defendant. You're not giving him a chance to be fairly represented by Hispanics on the committee or on the jury. All right, let's do this one. Test an appropriate, let's see. So here's the deal. Indicated that 3% of all births produce twins. This is it. Is the rate of twin births the same among very young mothers? Okay, so that's going to help us to do our alternative. First of all, our null hypothesis colon would be that P, the proportion of twins born, or proportion of teenage pregnancies that result in twins, would be what? 0.03. Good. So we start off saying it's the same as everybody, and then we see if we have evidence against that. So then the alternative says we're wondering if it's the same. So does that indicate higher or less than? It doesn't indicate higher or less than, so therefore we just don't know which direction, so we're going to go not equal to. So I don't know if it's higher or if it's lower. I just am wondering if it's different. HA means alternative hypothesis. That means that's kind of what I'm wondering about. Not equal to? Okay, the reason I know that it is the not equal to is because the question said, is the teen rate the same as the other one? Yes, and if it would say, is it higher or lower or something like that if it was a less than or a greater than? Yep. Okay, good. So let's practice this some more. Come on down here to the bottom. We're going to practice this parameter, null hypothesis, and alternative. So here we go. Number 1. A car dealer advertises that its new subcompact model car gets 47 miles per gallon. You assume the dealer would not underrate his car, so I'm assuming it's not going to be, he's not going to tell me it's 47 when it's actually like 60 miles per gallon or something. But I'm suspicious about his claim. So, first of all, the first question you ask yourself, is this a mean or a proportion problem? How do you know it's a mean problem? Because it's not a percent in there. Good. And it's about, what is the mu equal? Oh, wait, this is just like in words. What's this problem about? Okay, first, because it's mu, the first word I write is average. Remember, when it's a proportion one, we write proportion. So average miles per gallon for this model car. Okay, that's what this problem is about. And the claim, the null hypothesis, colon, is the claim. And what is the claim? Okay, but don't just put 47. Put mu equals 47 miles per gallon. Okay? Don't forget the mu equals. I'm pointing those things out to you because those are small little details that my students will miss if I don't point them out to you. Okay. Now, you are suspicious about that claim, so the alternative is, you think, if it's not 47, you think it's actually what? You think he's telling you it's too high and that it's actually less than 47 miles per gallon. You think he's screwing you over, and he's telling you, hey, it's 47 miles per gallon when it's actually not. So how do I write this? Mu is less than 47 miles per gallon. Okay, very good. Let's do one more, and then I'm going to let you start trying some on your own to practice. Here we go. Number 2. A package delivery service claims that it takes an average of 24 hours to send a package from New York to San Francisco. An independent consumer agency is doing a study to test the truth of this claim. Since there has been several complaints about the company not meeting its delivery times. So first start with the parameter. Is this a mean or a proportion? This is a mean problem, so the letter I write is mu equals average time. What is this? Average time to send the package from New York to San Francisco. Okay, good. Average time to send package from, and I'll abbreviate, NY to SF. Okay. Very good. Let's go ahead then and write the null hypothesis. HO, colon, mu equals what? Good. They claim that mu equals 24 hours. Okay. HA, colon. Good. You are suspicious and think it's greater than 24 hours. Okay, excellent. Now, I'm going to walk around while you guys are working on this side. So the very first question you ask yourself is what? Yeah, mean or proportion. That's the first thing. And then you write your parameter, mu equals or p equals, and then your null and alternative. So let me help you guys while you are writing these down, and then we'll check. Okay, let's go ahead. Let's go ahead and go over these. And no, well, I'll show you here in a second. I don't know what you're saying. So, hey, even if you have put yours away, get that back out right now because I need you to look at some of the details that I'm going to show you. Okay, that means your phone is away, and we're looking back at these. Here we go. So this first one, this is a mu equals the average size of this type of diameter. So our null hypothesis is that, make sure you put mu equals 6 millimeters and the HA colon mu is not equal to, because it just says, is it correct? It did not indicate bigger or smaller. Okay, now number 4 is kind of a lengthy parameter, but it does need to all be there. It is the proportion of heart attack patients that die from any cause in the first 30 days after being admitted to the hospital. Okay? So again, proportion of all. Make sure you had present tense and not past tense. The ones that do currently happen to die after the first 30 days. So the null hypothesis is that the proportion equals 16.1%, or you could write it as 0.161. You can write them as a decimal or a percent, but if you write them as a percent, do make sure you include the percent sign after it or it's wrong. 16.1% or 0.161. So it wanted to see if it improved. If it improved, what does that mean happened to the death rate? It went down. So HA colon P is less than 16.1% or 0.161. Okay, next one, number 5. This is the proportion of patients that undergo this operation and recover their sight. This probably should be proportion of patients who undergo this operation. If some English person was in here, probably would want that. And so the null hypothesis is that P is 0.30, and they're wondering if the new type of surgery increases the rate at which they gain their sight. So P is greater than 0.30. All right, number 6. Okay, proportion of this particular town's population that is New York State native. So proportion of Cortland, New York population that is New York State natives. Make sure it is present tense, not past tense. That's what happened in the past. So what did you say? Ah, okay. This is a good discussion. Okay, so hold on. This is a good discussion. The question is, can you say proportion of New York State natives that live in Cortland? And that would be wrong because the denominator is the proportion of Cortland. So the denominator is the town of Cortland's population, not the whole New York State natives. See, that's a different denominator if you said it the other way, and so it matters. It is proportion of the town of Cortland that is New York State natives. The null hypothesis, P equals 0.863 or 86.3%, and it just wanted to know if it has changed. So if we want to know if it has changed, then that's the not equal to. All right, the last one here is about the Super Bowl. And I'm sure that there's lots of marketing people that do all this testing to see if it's worth the money they pay for the astronomical Super Bowl ads. So P equals the proportion of the public that recognize its brand name and associate it with computer equipment. I got that straight from here because it said the goal is this right here. The goal of the company is that over 40% of the public recognize its name brand and associate it with computer equipment. Okay, so I found the words in there. So the null is that it is at 40%, and then you are going to see if the Super Bowl ads have increased that. Okay, and so then we've got ourselves a 3-day weekend. Hopefully we won't forget too much, and we'll do the class work on that part on Tuesday.